Our last section for test 3 period is inequalities involving polynomial and rational function. So I have given you a brief description of how you want to solve it. What I would like to do is start solving the problems and hence understand the process. Your first objective is to write down the given polynomial or rational inequality in factored form. So we'll start all our problem in class where the things are already factored. Then we're going to find the solutions. And we call the solutions in inequality the critical points. So first we do the critical points. For example, the first one will give you critical points at 0, -2, and 2. Then we do a number line, and on the number line we plot this critical point least to the greatest. So -2, 0, and 2. Now, each of these subintervals, I'm going to choose a point which I'm going to call the testing point. So I choose -3 here. Let's say I choose -1, +1, and 3. Then at each of these testing points, we're going to find the value of the left-hand side of the inequality and see whether we are maintaining the sense of the inequality. So what I do? At -3, I write -3 times -3 plus 1 times -3 minus 2. And then instead of the value, let's just talk about the sign of each of these factors. For example, the first one is minus, second one is minus, the third one is also minus, and 3 minuses multiplied will give you a minus. So the sign you get is minus. Then my testing point is -1, so I get -1 times -1 plus 2. So it should have been a 2 here. Let me change it real quick. It doesn't change the sign, but it should be a -2. So -1 plus 2 and then -1 minus 2. So now see what I have? Negative, positive, negative. So that is essentially positive. Next, we are going to try the testing point 1. So you get 1 times 1 plus 2 times 1 minus 2. Positive, positive, and I have the last one negative. So product is negative. And finally, you try the testing point 3. So you get 3 times 3 plus 2 times 3 minus 2. So that's positive, positive, positive. Product is positive. The sense of the inequality tells me that I want something less or equal to 0. So I want something 0 or I want negative numbers, which are the first subinterval and the third subinterval. So what I say, because of the equality, I say closed at all these critical points, and I say I'm going to choose anything in this subinterval or anything that is within this subinterval. And then I write the solution using union or OR. So the solution of this inequality is -infinity to -2 closed union, or you can say OR, closed 0 to closed 2. And I'm done solving the inequality. So this is essentially the process that we're going to follow for both polynomial and rational inequality. So I will solve a couple more problems for polynomial before we start talking about rational inequality. So again, this one, I have the polynomial. I want to get the critical points first. So let's do that. Critical points. And the critical points are going to be -9, -7, +5. I draw the number line. -9, -7, +5. I need my testing points. They can be -10. I can choose -8. I can choose this one. You can choose 0 because it is -7 and 5. And I can choose +6. Evaluate the function at all these points. So at -10, your function is going to take the value -6 times -10 plus 9 to the power 9, -10 plus 7 to the power 9, negative 10 minus 5 to the power 5. And again, I'm only worrying about the sign. So I get a negative sign. Negative 10 plus 9 is negative. Negative to the power odd is negative. Negative 10 plus 7 is negative. Negative to the power odd is negative. Negative 10 minus 5 is negative. Negative to the power negative is negative. So 4 negatives will give me a positive, and that's my final sign. Then I do it for negative 8. The same work. I get negative 6 times negative 8 plus 9 to the power 9. Negative 8 plus 7 to the power 9. Negative 8 minus 5 to the power 5. Now see, you get negative 8 plus 9 is positive, to the power 9 is positive. Negative 8 plus 7 is negative, negative to the power odd is negative. Negative 8 minus 5 is negative, negative to the power odd is negative. So I have 3 negative, 1 positive. The product will be negative. 0, that's the easiest one. So you do negative 6 times 0 plus 9 to the power 9. 0 plus 7 to the power 9. 0 minus 5 to the power 5. So the first one is still negative because it's just negative 6. So I get negative. Then I get 9 to the power 9, so positive. I get 7 to the power 9, positive. And I get negative 5 to the power 5, so negative. So I have 2 negatives, 2 positive. Product is positive. Finally, we will do it with the testing point of 6. So when I do it for 6, negative 6, 6 plus 9 to the power 9, 6 plus 7 to the power 9, 6 minus 5 to the power 5. So I get negative times positive times positive. 6 minus 5 is positive, so to the power 5 will be positive. All of them are positive. When I multiply, I get positive. This problem wanted you to find out f of x greater than 0. So you are actually looking for positive intervals. So since we are looking for positive intervals, we're going to choose all those intervals that are giving us positive values. And it is streaked, so you will have open dot. So that's one of the positive ones. Then I will have open dot here, and I will choose in between, and this one. So how do I write my answer? Well, I will say we're going to get, in fact, I made a small mistake, so let's correct that. See, this time you have negative times 3 positive, so that should be a negative. So the last one should not be my choice. So that is a negative. Let me just fix this. I will not get this interval. The testing point that we have chosen was 6. At 6 you get a negative value, so you don't have this. Because I wanted only positive. So the solution is negative infinity to negative 9, open this time, union or negative 7 to positive 5. Now I want fx greater than 0, but my critical points are, so critical points would be positive 5, negative 4, and positive 3. So on the number line, I will get negative 4, positive 5, and positive 3 and positive 5, writing lowest to the highest testing points. So they will be negative 5, I can take 0, can take 4, and say 6. At negative 5, you will get negative 5 minus 5 times negative 5 plus 4 times negative 5 minus 3. So you get negative, 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 3 of them, so sign will be negative. Then I will try 0. I will get 0 minus 5, 0 plus 4, and 0 minus 3. So the first one is negative, the second one is positive, the third one is negative. Total sign is going to be positive. Then I need the critical point 3 and 5, so the testing point is 4. So I get 4 minus 5, 4 plus 4, and 4 minus 3. So the first one is negative, and the other two are positive, so sign should be negative. And then for 6, I will get 6 minus 5, 6 plus 4, and 6 minus 3. And this time I see that all three of them are positive terms. So when multiplied, you will get a total positive as well. And I also needed strict positive, so open circle. This one is also positive, open circle. And so my solution set is negative 4, 2, 3, open, union, 5 to infinity. And that would answer the question for the solution of the inequality. As we talked about, the same process we're going to adopt for rational inequality. So you have to have all terms on the left-hand side, so that the right-hand side is strictly 0. For rational inequality, what we have to be careful about is the domain. Remember, we cannot have 0 in the bottom. So if one of the critical points, which you are going to see that one of the critical points are always going to be the bad points where the denominator is 0, even if the inequality requires you to have closed dot, I cannot put open dot. So how do I find critical points? Critical points are all points where both top and the bottom are equal to 0. So let's start working on the first problem. It is easy because the top is 0 at 4. So I will say critical points. It's pretty simple in this one. Top is 4. The bottom will be 0 at negative 3. Now remember, the bad point is negative 3 because that is on the bottom. So what I do now, I do the number line. Again, smallest to largest, so negative 3 to 4. Testing points, and let's take negative 4. This one I can take 0 and 5. And then you find the value or the sign of the rational function at each of the testing points. So you do negative 4 minus 4 over negative 4 plus 3. That's negative on the top, negative on the bottom, so this is a positive. At 0, we get 0 minus 4 over 0 plus 3. So the top is negative, the bottom is positive, total sign is negative. There is one more critical point, and this time the critical point is going to be 0 and 5, and the testing point is 4. That's between 0, that's beyond 4. The testing point is 5. So I'll do 5 minus 4 over 5 plus 3. So both top and bottom are positive, and I get a positive. So the signs are positive, negative, positive. In this problem, you wanted positive because you wanted greater than 0. It is strict, so I will have open dots, and my solution intervals are going to be these two. So how do I write it? We say negative infinity to negative 3, union 4 to positive infinity. This time we have greater or equal to 0. So let's first find the critical points. Critical points is where the top is equal to 0, and you will see 2 is where top is 0, and bottom 4 where top is 0. But 4 makes the bottom 0, so that's the bad point. I have to be careful about it. Draw a number line and get your test points. So 2 and 4. Test points are going to be, so I can take 0 here, I can take 3, and I can take 5. So when I'm evaluating at 0, I get negative 0 plus 2 over 0 minus 4. So the top is positive, the bottom is negative. So the total sign is a negative. Now I am evaluating at 3, so I get negative 3 plus 2 over 3 minus 4. So both top and bottom are negative this time. So it's minus 1 over minus 1. And I say negative over negative, so the total sign is positive. Finally, I do it at the testing point 5, so I get negative 5 plus 2 over 5 minus 4. So the top this time is negative, the bottom is positive, the total sign is negative. So negative, positive, negative. I wanted greater or equal to 0, so positive or 0. So I will get closed dot at 2. It should be a closed dot at 4, but because it is the bad point, I cannot take this as my point, so I have to put open dot. And this is the only positive interval. So the solution set is going to be closed to open for. Okay, so now we go to our next problem, and this problem is x squared plus 2x over x minus 1. Again, you're finding the critical points. So finding critical points would be easier if I write both top and bottom as factor. So you write first as x times x plus 2 over x minus 1 greater than 0 and start working. So critical points are 0, negative 2, 1. 1 is the bad point because it will make the denominator 0. Number line. Lowest is negative 2, then I have 0, then I have positive 1. Testing points, I can take negative 3, I can take negative 1, I can take maybe 0.5 here, and then 2. What happens at negative 3? I get negative 3 times negative 3 plus 2, and use the factored form. It's easier to find the sign. See, the signs on the top are negative times negative, bottom is negative. So positive over negative, which is negative. What happens at negative 1? It's negative 1 times negative 1 plus 2 over negative 1 minus 1. So I get negative times positive over negative. So total sign is positive. The next one I will do is at 0.5. That's the testing point. So it's 0.5 times 0.5 plus 2 over 0.5 minus 1. So both terms on the top are positive. The term on the bottom is negative. Total sign is negative. Finally, I do it for 2. So I get 2 times 2 plus 2. Both are positive. Over 2 minus 1, positive as well. So positive times positive over positive. So that should be positive. And you wanted a positive sign because you wanted strictly greater than 0. Strict. So positive intervals, I'm going to put open dots. So that and then this one. And I will say this is the positive interval and that's the positive interval. So the solution for this rational inequality is from the test, the critical point negative 2 to 0, open, union 1 to infinity. Okay. Now this inequality that we have, not all the time are on the same side. So what I will do, I will first subtract 2 over x from both sides. So I will write it as 1 plus 2 over x plus 1 minus 2 over x less equal to 0. Then simplify the left hand side. So clearly the common denominator is going to be x times x plus 1. The first term you write as 1 over 1. So you need to multiply x times x plus 1 on both top and bottom. So I get x times x plus 1. The second term already has x plus 1, so you multiply x on top and bottom, so plus 2x. The third has x, so you multiply x plus 1 on top and bottom, and you get plus 2 times x plus 1 on the top. That is less equal to 0. So let's continue simplifying. So what I have now is x squared plus x plus 2x plus 2x plus 1 on the top. The bottom is x times x plus 1. So do not distribute the bottom because remember essentially we're going to factor. It is already factored. Top is then x squared plus 5x plus 1. And I just want to take a moment here and try to make sure that I have done it right. And I already see that I made a mistake. Remember the sign was a negative, so it should be a negative here. We have to fix it. So that should have been a negative 2x. Let me actually fix it here first. So it was a negative 2 times x plus 1. What does that mean? When I distribute the negative 2, I get negative 2x minus 1. Actually minus 2. Right. So this calculation changes a little bit. So it's x squared. The 2x cancel, so it's plus x, and then I have a negative 2. And remember, we are going to factor the top. Okay, so the factors on the top is x plus 2 times x minus 1, because you needed two numbers that multiplies to negative 2 and adds to positive 1. So multiplies to negative 2, adds to positive 1 are 2 and negative 1. That's how I got my factors. The bottom is x times x plus 1. So now we are ready to write the critical points. So critical points. And if you see, there are 4 of them. Negative 2, positive 1, 0, and negative 1. So draw the number line. You will have 5 testing points, longer problem. It's negative 2, negative 1, 0, and positive 1. So I can choose negative 3. That should be negative 0.5, or actually I should say negative 1.5. Between negative 2 and negative 1, negative 1.5. This I can choose as negative 0.5 between negative 1 and 0. Between 0 and 1 I can choose 1.5, and beyond 1 you can choose 2. Okay? Testing points at negative 3. So what I get, use the factored form, so you get negative 3 plus 2 times negative 3 minus 1 over negative 3 times negative 3 plus 1. So minus times minus over minus times minus, that's a plus. Negative 1.5, you get negative 1.5 plus 2 times negative 1.5 minus 1, negative 1.5, negative 1.5 plus 1. So I get positive, negative, negative, negative. So it should be a total sign of negative. Negative 0.5, I will get negative 0.5 plus 2 times negative 0.5 minus 1 over negative 0.5 times negative 0.5 plus 1. So positive, negative over negative, positive. Negative, negative cancels, you get a positive. Next testing is at 1.5, and I should have said 0.5 again because it should be between 0 and 1. So 0.5, so I get 0.5 plus 2 times 0.5 minus 1 over 0.5 times 0.5 plus 1. So you get positive, negative, positive, positive. That's negative. I need to do one more testing, and this time the testing is going to be at 2. So you will do 2 plus 2 times 2 minus 1 over 2 times 2 plus 1. And I see that all 4 of them, both tops and both bottoms, are positive. So essentially I get a positive sign. But in this problem, I needed less than or equal to 0. So first, identify your bad points. Your bad points are where the denominator is 0. So that is bad, and this one is bad. I needed equal to 0 or less than 0. So I will say negative 2 should be closed because it is not bad. But negative 1 should be open because it is a bad point. The other negative is between 0 and 1. Again, 0 is a bad point. 1 is good. So I will put that sign. So these are the only 2 intervals that I will choose for the solution. And I will say that the solution set is going to be closed negative 2 comma negative 1 open union 0 open comma 1 closed. So this time we're a little fortunate because all the terms are on one side and the right hand side is 0. So I'm going to find critical points first as usual. So the critical points for this inequality is 1, 2, and 4. 1, 2, 4 testing points. 0, I need to take 1.5. This one you can take 3 and I need one more, so let's call it 5. At 0, I get 0 minus 1 to the power 4, even power, 0 minus 2 to the power 3, odd power, 0 minus 4. Negative to the power even is positive, negative to the power odd is negative, over the bottom is negative, so the sign should be positive. Then I have at 1.5, so it's 1.5 minus 1 to the power 4, 1.5 minus 2 to the power 3, over 1.5 minus 4. Again, negative to the power even, or positive to the power even, both of them are positive. So this sign is always going to be positive. Then I have negative to the power odd, so that's negative. The bottom is still negative, so I still get positive. Okay. Now I do it at 3, so I get 3 minus 1 to the power 4, 3 minus 2 to the power 3. So now the top looks like it is positive all the way, but the bottom is still negative, so the sign will be negative. And then finally we have the testing point of 5. So 5 minus 1 to the power 4, 5 minus 2 to the power 3, 5 minus 4. So that is positive, positive, positive. So essentially you get positive. Now do not forget your bad points. Your bad point, there is only one of them, and that is 4 because it makes the denominator 0. And I want greater than or equal to, so closed dots, and I want greater, so positives. So closed dot at 1, closed dot at 2, but open dot at 4, even though it should have been closed, but because it is a bad point, it should be closed. These are my positive intervals. Okay, so my solution interval is going to be negative infinity to 1 closed, union 1 to 2 closed, union open 4 to infinity. Because I have 1 closed, so I'm not actually getting rid of any point. So those two I can actually combine together and say it's negative infinity to 2 all the way. And that should be your final answer to this inequality. And that solves this problem. It is also the end of our study of polynomial and rational function. We will have the test on Thursday, and then we will start talking about inverse function and exponential and logarithmic function.